able to see every aircraft anywhere in the world at radar-like performance at any given time. So it's a good position to be in as a company, but I think a very exciting position to be in for ICAO in this conference as well, with setting the stage for where we're going as an industry. You probably all know this, but the system is a pretty complicated system in space, but simple on the ground. We're taking all the data from every aircraft around the world from their ADS-B transponder, receiving it in space and transmitting everything back down to the ground the same way you would do with a ground-based ADS-B receiver, or very similar actually to how you would process the radar data. It goes into the automation platform and is being presented to the controller the same way you would do any other form of ATS surveillance. So it's a new layer of data in the automation platform, but it acts and behaves exactly the same way as any other layer of data would that you would get from a ground-based receiver. We're, as I said, weeks away from completing our constellation. One more launch to go. This launch will put the last 10 satellites in space. We currently have 65 satellites operational. So it says 50 here, but we're at 65 right now. We need 66 to complete global coverage, and the remaining satellites are all spares that are being launched. And that's partially to make sure that we meet the performance requirements that are necessary for separating air traffic and safety of life services with this constellation. It's all been done through partnership. Aireon was a subsidiary through Iridium. We very quickly started off with partners such as NAV Canada, ENAV, NATS, Naviair, IAA. As most of you will know, NATS joined us most recently as one of the investors in Aireon. But it's been a partnership with long-lasting knowledge in the industry as well. Partners like Harris, partners like Thales, but also partners that have really joined us later on, like FlightAware and most recently Airbus, that are starting to work with us for all kinds of ways of utilizing this data in an operational environment, whether that is as an ANSP or as an airline or as an analytical company for this data. The partnership also was very much the base of how we approached how do you use this data in reality. Obviously, there is a lot of ways you could use data coming from satellites, but this was never about just the data from the satellites. This was about a concept of operations that we started very early on with our customers. It was our customers that had a vision, NAV Canada, NATS, around what they wanted to do in the North Atlantic. There was no surveillance. What could you do different with surveillance? And the whole build and the testing plan around the Aireon system was all based on what performance do you need on the ground and what level of confidence do you need as an air traffic controller to be able to utilize a completely new source of information to separate two aircraft safely over oceanic airspace. That was the start. Obviously, we're now in a point where we can actually do that testing. We've done flight testing with NAV Canada, with the FAA. We're in a point now where a lot of our customers are doing operational testing, integration testing in their operations platforms. So you're getting to the point where the performance part of the data has been proven, and it's been proven by various of our customers, and we've got one step left, and that is finalizing the safety case with our regulators. And that's something our customers and our partners are currently doing, and that Aireon is pursuing as well with the EASA on a much broader scale. The concept of space-based ADS-B is new in the way it's currently being used and the way it's designed, but obviously the data is not new. It's ADS-B data. But the way we approach it is very similar to how you normally would approach ATS surveillance as a system. You're utilizing overlap between different sensors to achieve a performance that you need as an air traffic controller. High availability, a high level of confidence, a high level of confidence that the system will see and detect all targets within a certain period of time, and a low latency. That's what our satellite system was designed to do. So there is overlap between the satellites. There is a lot of redundancy built within the satellites, but we've also approached something such as cybersecurity from that same concept. We approach cybersecurity as a design. Everything is completely encrypted on the satellites. The satellites are off the grid. At no point in time is anybody able to bring anything into the data feed. But more importantly, we're also using the data to start validating what do we get from the aircraft. Is the aircraft actually where it says it is? One of the most common issues that states still have with ADS-B. Is this GPS position that the aircraft gives me actually where the aircraft is? So what we did was build the system towards what ICAO has long defined as what is ATS surveillance. So we're not just building a sensor, we're building an ATS surveillance system that is a new feed into an existing environment. That was also the approach we took on the regulatory side. We saw, together with our customers, there's two main ways of utilizing this data if you want to use it for safety of life. There is your traditional way in VHF airspace, where this technology has very clear performance parameters it needs to meet to be considered ATS surveillance. And once that definition is set and once that performance testing is done and the safety case is complete, ICAO already has all the guidelines needed to operate with ADS-B as an ATS surveillance source. The new one was, what do you do in airspace where there is no VHF? CPDLC, RCP-240. So that's where ICAO and the SASP have put in a lot of effort over the last years, really since the last air navigation conference, to define the separation standards that could be used. And glad that they're in a process of being finalized. I think the SASP has finalized the standards, and they're going to the Air Navigation Commission for their approval and publication in PENS ATM. So just going back into where I started off in 2011, in Air Navigation Conference 11, this was there was no global ATS surveillance. In Air Navigation Conference 12, this was an idea. We're now in Air Navigation Conference 13, and 27 ICAO member states are actively going to use this data. They are in the process of being connected or are already connected. Some of them have already integrated the data in their operations environment. Some are training, some are planning for operational trials. But more than 20 ANSPs outside of those 27 are working on the ConOps, are actively looking at integrating the data, are testing stale data, are looking at performance comparisons against radar. So we've come a long way in a 4-year period since the last time we had a chance to talk about this. We've seen an enormous amount of adoption in regional strategies, whether that's the North Atlantic or discussions in Latin America's ICAO panels, or discussions in the South Atlantic or in Asia Pacific. And we're seeing a very strong recognition of the benefits this could bring. Not just the benefits to fuel burn, where this all started, it was around efficiency in the North Atlantic, but specifically, what are all the other things you can do with this type of data, from safety analysis, from flow management, from efficiency perspective. And a lot of dialogue has been taking place at the ICAO level, which we're very glad is happening. We're very close to going from a position where this is the knowledge an ANSP has in big parts of the world. It's your airspace. It's the information in your airspace. And unless you have willing neighbors, that's all you're going to get. Unless the neighbors provide you with information on border crossings, there is no flow management outside of your airspace. There is no safety net around your radars. So this is what we're currently working on just with the ASECNA partners, and this is where we're going to be including our AT&S partners and Seychelles in Africa. Almost 2/3 of the African continent by 2019 will have full ATS surveillance applied to any ADS-B aircraft in their airspace, which is a significant step from where the continent is right now. And I really like to thank our friends at ASECNA and AT&S and in Seychelles for taking this step with us. So far, the data is working great in all their environments, and we're really happy that that we're moving with them. And this is not going to be the end. We're going to see a lot more coming soon. We're very close next year, early next year, from going from a fully procedural North Atlantic airspace where we thought where every aircraft was the reality, to actually having an ATS-enabled North Atlantic, an ATS-enabled Bay of Bengal, an ATS-enabled Mumbai FIR, where we will know exactly where every aircraft is, and the controller will simply look at the aircraft to determine what it is doing and where it is going. With that, I think a lot of ICAO's strategic objectives are coming within reach. We're all here to talk about what is next for ICAO and the Global Air Navigation Plan. Again, the last time I was here at one of these conferences, the Global Air Navigation Plan barely spoke about this capability because the capability wasn't there. We're 4 years down the road now, and all our traditional approaches to what is air traffic surveillance can basically be rewritten. Our traditional approach to flow management, to arrival management, to even analytics on data of traffic in remote and oceanic airspace or in procedural airspace, all of those things will change in the next upcoming month. The whole concept around no country left behind, for instance, we're allowing a leap into the future with a lot of our customers by just going straight into an ATS surveillance environment without any ground-based infrastructure need. We're driving a lot of safety initiatives with our customers. We're working on a lot of these, and I'll talk a little bit about that in a little bit. More importantly, I think we did this one together with our partners at FlightAware. What we all thought for a really long time was the truth. Where did the pilot last say he was, and where will he say, where is the system saying he is right now, shows when you actually look at the real data is really far from the truth. We're seeing aircraft, and we're actively seeing this right now on a daily basis, even within Aireon and with our partners, that aircraft make massive deviations around storms that we all know are happening, but we're just not seeing it. And it's a very different situation to be in a knowing situation with an aircraft and with separating two aircraft than thinking what the reality is. We're also going to be able to provide a way into CDM with this type of capability for a really long period of time, and it was really not until I think FlightAware started providing positional data and flight plan data to a broader group of customers. CDM was something that was only possible if you had people cooperating. You had two ANSPs or an airport ANSPs or an airline that were willing to share their data. The difference now will be there is data, big data, global data, and that data is available. And that data is available to anybody that wants the data or that needs the data. So the whole concept around CDM will now be around, I can get the data. What can I now start saying to my airlines based on the information I get from the data? Or what does the airport learn from this data when the ANSP is not willing or not able to share any of that information? It also brings a lot of potential alternative solutions to problems that in the last air navigation conference were still up in the air, and a lot of these are driving a lot of the tasks that ICAO is currently undertaking. Height monitoring, we'll be able to do that from space. Spectrum analysis, how much use of 1090 is there in various parts of the world, and where are the hotspots of potential over-interrogation of transponders? Just the basic question is, how many transponders are there? How many version 0s? How many version 1s? How do they operate? How do they perform? Is there any history in the last year on a global scale of wrong data coming from a transponder? We can start building databases for that type of information and share that with the regulators and for analytical purposes. Safety performance monitoring. Does a resolution advisory or traffic advisory always lead to an airline actually reporting those? In the ocean, we're seeing a lot of them right now, and a lot of those are actually going unreported. So what can you learn from that? What can you learn from that from a safety perspective? And as a regulator, what do you learn from that in the detection of hotspots? We're seeing something similar on the GPS side. You can start seeing, based on what I'll get to a little later on, the ability to start doing multilateration from space. You can start seeing where GPS is inaccurate, where are GPS positions coming from the aircraft not meeting where the aircraft actually is. And you can start doing big data analysis on that type of thing. Natural disaster recovery of conflict zones is another one. We've started working and having discussions, for instance, on the Somalia airspace with ICAO, because these are just long-standing hotspots where it was almost physically impossible to put hardware on the ground. Here's an opportunity right after a natural disaster or a conflict zone to actually bring surveillance back in without having to wait until the conflict zone is in a sort of stable environment to do that. A little bit about position validation. This is actually being presented at the ESAF's conference in Berlin. What we will be able to do is start looking at validation of the position of an aircraft because of overlap in satellites. It's a principle you all know as wide area multilateration or multilateration. But the principle for us is the same. We've got multiple airlines with multiple satellites with time available on the satellite, and you're able to do calculations on where that aircraft actually is. And we're very excited that we're getting that down to a level where you're very close to multilateration, around 0.25 nautical miles. At that point, you can start to say, independently from what the aircraft says it's doing, that you actually validated the aircraft is doing that. It's a big problem for a lot of states. It's a big driver for a lot of states of not using ADS-B as a primary source of surveillance. This will be a big solution to that, and I'm happy to see where this is going as Aireon, but with some of our customers, we'll be working on this over the next months. We're looking at all kinds of environments, whether it's high density. You see a couple of the high density airspaces that we've been talking to our customers around the data, to the low density environments, but also to low altitude. We've started following, for instance, in the case of Australia, the Royal Flying Doctors over a period of a week, and just started following all their aircraft, and a lot of them are actually currently flying outside of radar coverage. The same in some of the water airplanes close to the ocean floor. And you can see even in the more denser airspace, the traffic patterns in the Middle East around some of the big airports there. So a lot of encouraging output on our end. In the end, this is going to be the reality going into Air Navigation Conference 14. The next 4 years, a lot of what we thought was real shows very different. We now have the data. We have the data to do analytics. We have the data to actually look at conflicts that happened, safety occurrences that happened, performance, what is the actual performance versus what we thought the performance was. We're seeing a lot of data and have done a lot of analysis with the airlines already on what is an optimal flight profile versus what do you think is happening and what is actually happening in the airspace. So the reality that the globe has will change very, very soon. The next couple of weeks, and you can already see this is all from live data, and you can see at our booth the data right now. But we're seeing the data in the world in a very different way right now. So that was the message I had. Any questions? Happy to take them. Thank you.
Concerning the excellent presentation and exciting technology to look forward to. The question I had is the transponder reception will be received by satellite. The download, would it be online?
We're going to get the question repeated in the microphone so everybody can hear it.
Yeah, thank you. Excellent presentation. I was saying earlier, an exciting technology to look forward to. The question is the download of the information back to an individual ANSP. How would that be utilizing the same satellite that is receiving the ADS-B signal? And the second follow-up to that would be every individual ANSP, would they require a reception or a satellite receiver, or would it be a ground network to deal with the data?
Yeah, the way our system is designed, the path of the data coming from the aircraft down to the ground takes place over initially the same satellite, but it gets hopped over multiple satellites. We bring all the data down in one location, but obviously there's a full fallback setup in that structure. The way we've approached it is all performance-based. What we're trying to do is meet air traffic surveillance standards that are currently in place. So it's exactly the same way you would approach establishing a radar network or establishing a ground-based ADS-B network. So for us, the redundancy needed to be built within the satellites, within the system, within the ground systems. But that's the way we bring it down to the ground. So the data is on the ground in the facility that Harris built for us that is also doing the ADS-B data for the FAA. From there, it takes an MPLS line to the ATC provider. So it comes into your facility very similar to, it's almost a virtual radio. It comes in as any other ADS-B station you would have with a monitoring equipment on our end, just to make sure that the performance is still the same and for the encryption purposes. But in the end, at an ANSP level, it's a glorified router, and I'm probably offending my engineers if I say that, but it's a glorified router on the ground that brings the data in. All the reception takes place on the satellite, so there's no big dishes on the ground. It's very different from a VSAT structure.
Thank you for the good presentation. We have seen at the WAC in Madrid that there was an approach of getting an EASA certification as a surveillance service provider. What's the timeline now on when will this happen, actually?
Yeah, so the process is well on its way. EASA has done multiple audits, and the way we're approaching it is we're trying to take the same approach you would do as an ANSP. So Aireon has a safety management system. We're building a safety culture within the company. But in the end, EASA has to take the whole constellation and its performance into consideration as well. So basically the last step of this is right after the completion of the constellation. So I think the planning is Q1 of 2019 to complete that. But most of the work has been done, and it's all on documentation on our process and procedures. So that's in an ongoing state right now. All our operations is basically in a shadow mode for Aireon right now. So our operations centers are ready. We've done disaster recovery testing with the EASA there. So that's where we currently are, but we got to wait until the last couple of satellites are active to sort of put the final stamp on it.
Thank you.
Yep.
Can you elaborate a bit further on the timeline for position validation improvement? You said about a half nautical mile. Is that in a year, 2 years, 3 years?
Yeah, so the question is to clarify a little bit on the independent position validation and the timeline for that. I think internally, and I might have to correct that later on through Jesse, but I think the internal timing is it requires the new software to be uploaded, and I think that is planned to happen in mid-19 or so, as part of our next build. The testing has been done on the ground, and that build, I think, is being put in place for the FAA, and that's basically our next build. It's a very similar approach that, for instance, Harris takes on the ground in the US right now with their ground receivers.
Good afternoon. One of the problems that we had in the past, not that long ago, was the coverage, the silent cone immediately under the satellite. Is this problem already solved?
Yeah, on our satellites, there really isn't a silent cone, and there is so much overlap. Every satellite is multiple receivers, so the difference between some of the other companies out there that are doing something similar, we've got 24 receivers built in a single satellite. They're all slightly looking at the target in a different angle, and then you've got overlap between the satellites as well. So what our experience is right now. There's no cone of silence underneath the satellite. And in fact, we were initially designing this to be an en route system. So there was always the question, well, what happens to lower flying aircraft or weaker transponders? But you can show some pictures on complete airports like New York or others where we're seeing the aircraft on the taxi track and the runway. I think the first time our engineers looked at real data, it was in Memphis, I think. They thought that they had discovered a bug in the system, but it turned out to be all of FedEx's aircraft standing still at the gate that kept a transponder on, and it just became this big blob of information that came out of the airport. So we're very happy with the performance so far. It's been a lot better than what it was designed for. Good. If there's no other questions. Thank you. Thanks.
Okay. Thank you once again. I'd like to remind you that our next presentation will take part at 5:15 p.m.